Hello, this is Mr. Manley, and I want to do a problem here that involves work. And if you know about physics at all, you know that work is equal to force times distance. But if you're watching this video, you know about dot products. And I can also say that work is equal to F some vector dot D. And this is really exciting because if I didn't have that, look at a work problem. I would have, say, a point P that is at a position 1, 3, and a point Q that is at position -3, 5. And I'm going to say that I want to move from point P to point Q. So if I look at where those points are, let's go like this. I'm going to give myself a little XY axis here and say that I have P at 1, 3, like here. And I'm going to say I have Q at -3, 5, like here. And I want to move from point P to point Q. I want to move like that. And I'm going to move there with a force. And I'm going to know that the force vector is, so I've got a force vector that is equal to -2I plus 3J. And that's just changing it up for you a little bit and remembering this is a way that we can talk about vectors in the IJ form, right? All this is maybe what you're more familiar with is this form, -2, 3. So no big deal there. So there's this force vector that is acting like this, and I'm going to draw it in its standard position. So it looks like this, -2, 3. So there's some vector like that. That's vector F, and that is acting on some particle, say there's some particle, and it's moving that particle from position P, and it's moving it along it until it gets to position Q. And I want to know how much work is done. Well, if I think about work as force times distance here, that's going to be quite an involved problem. And hopefully you could understand that it would involve a projection. And again, if you're watching this video, you know about dot products, and I'm thinking you might also know about projection. So I would want to take this Q to P, and then I'd take F and say that F is this vector here relative to P and Q, and then I need to find its projection onto this, so I need to find out how much that vector is and the distance from P to Q. So you see it's getting really involved. But this guy here makes it really easy, that work is force times distance, and work is also F dot D, makes this a piece of cake. So all I need to do the work here, and I don't know if physics students do this problem like this. If you don't, it should be pretty exciting to you, that all I need to do is the force vector, which is this, the dot product with the movement vector. So I just need to convert this into a vector. Now you have to stop and think about this to understand my vector D here. So I'm doing my vector D, right? So do you understand that vector D is -4 because I'm moving from -3 to from P to Q. I'm moving from 1 to -3, so that's -4 in the horizontal direction, and then I'm moving up 2 from 3 to 5 in the vertical direction, so that's going to be 2. So I've got my force vector here, I've got my distance vector here, and then I just do the dot product, and that's 8 plus 6 is 14. And that's the work. How easy is that? Now, you don't have to know this so much if you're not a physics student, but the units for work are joules. But I just found out that the work is 14 joules, and all I needed to know was to get these two vectors. Now, I'm not going to take the time on this video to do this. I'm going to do it on another video. But I could take a problem now and say there's like a problem like a guy pushing a broom at a 30-degree angle. So it's like this, and then the broom is coming down here. It's at 30 degrees, and then he pushes the broom for 30 feet. How much work is done? It's just two vectors. I'm going to find a force vector, I'm going to find a distance vector, dot product, and I've got the work. That's a pretty neat, it's a pretty neat, nifty little thing, this dot product. And at the beginning, when you first learn dot product, you might mean, what is that? Why do I multiply that by that? Oh, it's just multiplying vectors. Why do I multiply vectors like that? But we find that the use of it is really exciting, particularly in an application like this.